Hi, everyone. Welcome to the online meetup of GDG Cloud Budapest community. I'm Kamilla Kesner, co-organizer of the meetup group, and I'm going to be your host today. We regularly organize events like this, so if you want to keep up with the latest trends and technologies around GCP, join the community and learn from your fellow GCP enthusiasts and experts. Before we start, I would like to thank the main partner of the GDG Cloud Budapest community, Deutsche Telekom IT Solutions, for their support. DTITS is the largest ICT employer in Hungary, and it serves its international corporate customers in the areas of software development, system integration, and operation. DTITS actively supports this community, providing resources and often contributing to the life of the community with speakers from its colleagues, just like today. So thank you for our main partner for enabling this kind of knowledge sharing, and let's continue with some technical information. As always, we're very happy if you're curious and ask lots of questions. So this session could turn into a discussion a little bit. And if you miss anything, don't worry, because within a few weeks, the recording will be available on our YouTube channel called Clouders Club, where you can rewatch the whole session. Find the links to the GDG community and the YouTube channel on the slides and in the chat. And that's it from my side. Thank you for your attention. With that, I would like to give the floor to our speaker, Tamás. The stage is yours.
Let me welcome all of you during this talk. So my talk will be about automated and secure landing zone on Google Cloud Platform. Before starting, let me introduce myself. My name is Tamás Szebeni, Cloud Architect and Security Engineer from DTIT. I'm providing consultancy for our customers on building landing zones on Google Cloud Platform for almost 4 years now. And before that, I have a full stack developer experience for more than 12 years. And I have GCP certifications for like 6 years now. So this talk I will talk about what a landing zone actually is, why it is important, what are the components of it, a bit about cloud governance. It is important for companies, and also as platform operators, we are interested of the infrastructure as a code aspects. I will talk a bit about CI/CD pipeline. And I will mention a few workload blueprints that we are mainly working on, and also mention a few integrations, a landing zone. It is recommended to have for a landing zone, and I will provide a bit of a demo at the end, and after that we will cover the questions and answers section. Please follow the recommended way from Kami. First of all, I just hope that you can hear me well. Thank you. So let me start. For motivation, what is the motivation to have a landing zone? Actually, the main driver for it could be like addressing some of the limitations of on-premise systems companies usually facing with. Is that for on-prem system, they have limited set of resources that is very opinionated setup. There are vendor lock-ins, vendor-specific solutions, and this limits their growth and business continuity. They seek for solutions for having scalability, agility, cost-efficient solutions at the same time, and it is very difficult to meet at the same time, so that they need to help. Like during our consultancy, we are usually helping them to make it a standardized way, put it in structure, and avoid the common pitfalls of going to the public cloud. So as the picture suggests, it is a multi-phased approach. We start talking to the customer, designing according to their requirements, using some of the blueprints, migrating some of the applications and data, and we iterate with optimization. And actually, what is a landing zone? It's modular, flexible, scalable configuration, because without it, it is just a vanilla environment with lots of different options like building blocks and we need some guidance how we can connect these building blocks following industry standards to ensure security controls. At the same time, each other allow different teams to consume these services and provide workloads and go to production with just a little cost as possible. And for having such landing zone, there are several different pillars that I will mention. Next, let me mention the first pillar, which is the resource hierarchy. So for GCP, without organization resource node, which is provided by registering into Cloud Identity or Google Workspace, you can just have projects and you can create your resources within those projects. It works for personal use, but it does not work for companies. For companies, they need such resource hierarchy, a top level node, having forgers within forgers, and at the end having projects to host the resources. So that this is important that given this structure, there are also inheritance from the top to the bottom, like IAM policies. Next pillar would be the identity management. We need some place where the users can be stored, users with their attributes. For small companies, it could be just Cloud Identity or Google Workspace. These can host their user identity pool directly, or it could be a federated solution. For larger companies who already has existing LDAP service or Active Directory, there is a recommended integration to Google Cloud through Cloud Identity. And this is recommended also because of this way the user lifecycle management is also ensured. So there is no need to do manual user deactivation after user offboarding, something like that. So I was mentioning Cloud Identity, but it already provides, I was mentioning the user management, but it is not the only feature that is important because we can group these users into groups. We can maintain their managed devices, and Cloud Identity can be upgraded to Google Workspace license, which means that the corporate can consume Google Workspace services. For example, branded Google Mail application with their own custom domain address. Some of the security features are provided by Cloud Identity, very important. For example, SSO, this single sign-on integration. Strong password policies can be enforced, and the multi-factor authentication, which is mandatory nowadays to have. And it is important to mention that the alerting and monitoring part of it is independent from Google Cloud. So it has its own monitoring part, alerting part, and besides that, it still can share some of its logs with Google Cloud Platform. And Cloud Identity has its own admin concept. There is a super admin role that we should protect because that is the most important or most secure entity for the Google Cloud Platform, that it is really important to protect the super admin role by having multiple super admins, but sealed, like not used daily. So we have users, we have groups, we also need some permissions. And the IAM, the Identity Access Management, is important a way that to understand how we can provide permissions to users. First, we would like to group the users and some service accounts, like technical accounts for integration. We would like to group them into user groups. And we write IAM policies that for a certain user group, we provide a certain role which has multiple permissions on particular resources. So this is how we provide the permissions to services via IAM. Mainly, this is a very introductory explanation, but we also need it a secure way. So there are some security recommendations best practices that we need to keep in our mind. One thing is, I already mentioned that there should be multiple superadmin accounts, but protected. Even if some of them could compromise, we need some solution for a break loss scenario, for emergency situations. We should avoid using default service accounts on Google Cloud Platform. We should follow infrastructure as code, and like for the web console, most of the cases we just only need viewer permissions, but otherwise we need to rely on automation to execute any changes. For JIT access, that is a way to provide just-in-time access, not for emergency situations, but to provide evaluated access for some cases. That will be replaced by the PAM, Privilege Access Manager. It is important to use it, for example, for support cases or ops operation when a certain ticket is created, then it can authorize the ops team to do certain changes to have access, temporary access to some of the secret data, for example. We should follow least privilege principle, which means that only the necessary permissions should be provided to users they really need to do their job. Otherwise, we should find ways to implement it via automation or use JIT access. I was mentioning service accounts. Those are technical accounts. Usually and historically, the most common way of integration was using service account credential keys, but that is unsecure. Better to use workload identity federation with service account impersonation. I will not go into very detail for these topics. Anyone who's interested in more detail for those specifically can look into it, but I will touch them during the talk later. There is also a way that we can provide IAM grants conditionally. For example, we can create admins who can provide certain IAM permissions for others, only certain IAM permissions, but not all of them. And also we can create custom IAM roles. The predefined IAM roles, they provide a bit broad permissions. Usually for companies with higher security requirements, we are customizing these. We are creating custom IAM roles specifically for their need for supporting their own processes, workflows. And it also follows the least privilege principle that way. And these are the very basic IAM recommendations that when we took these and we communicate with the customer, we form IAM concept specific to that customer. And also we create some of the groups, user groups, as default user groups here. Billing admins, developers, DevOps, logging, monitoring, admins and viewers, organization admins, security admins, and team editors and viewers. Teams are the workloads that use the platform services within the landing zone. This is an example provided by the enterprise checklist and also the Cloud Foundation Fabric, which is a landing zone blueprint that relies on these user groups. I was mentioning the resource hierarchy, but to understand together with IAM concept, here you can see that there are certain purposes, different forgers, networking, security, teams, sandbox. Within teams, there are team 1 and team 2. Within that, there are prod and dev, different environments for those teams. So this way, we can provide IAM permissions at forger level, at very specific forger level, to provide their necessary permissions and let it inherit down to the actual projects within that forgers. So this simplifies the IAM setup a lot and ensures consistency across the whole organization. The next main pillar of landing zone is the network design. that there are several questions, and most of the time we spend with the customer discussing these questions, that how the network should look like for their case, because there are so many options. There are certain opinionated versions. They are coming from the on-prem, or they would highly utilize the possibilities of the cloud, the software-defined networking. At the same time, they have some scalability or security requirements that are important to fulfill. It is a broad topic. I'd recommend to look at the article rather than relying just my 1 hour long talk on this topic. First thing is that should it be decentralized? Like this is the most basic, most common solution to have a hub and spoke topology. Otherwise, it's also called star topology. In this picture, there is an on-premise network on the left, and within the Google Cloud environment, there is a hub, a shared resources VPC. That is the hub which has the connection to the on-premise network, and it has VPC peering to the actual spokes. And for those VPCs, they are like the team VPCs for different use case. They receive such VPC, and by using VPC peering, it involves both host and service project resources. It requires network setup on both sides, both the hub side and the spoke side. So it is not only a platform team who provides the landing zone to the workloads, it is also the workload's responsibility to ensure it is well configured. Because for VPC peering, you need to ensure the firewalls and routes are configured properly, vice versa. This is also an example that the landing zone blueprint Cloud Foundation Fabric I mentioned, it also provides. The other option, which could be like, should it be centralized? There is a separation of concern. For example, different teams within the organization. For example, there is a security team, and there is a network team, and there are workloads. Workloads don't want to bother with network setup in a way that the network team requires them. Also, a security team should ensure the security part of it without conflicting with the other teams. So shared VPC comes as a solution for that case. For that, the dedicated network admin team controls governance over connectivity across the whole organization. And they have a host project where they have a VPC network, and they share specific subnets from that VPC to the actual teams to their service project. And actual teams host their resources within the received shared subnet within their service project. And that way, all the administrative part, like firewall routes and IP address management, remains in the host project, and as workloads, they can just consume the subnet, put their resources within, and it will work. Our next pillar for the landing zone would be the cost management part. We already have identities, hierarchy, permissions, networking. So this is cost management. And the flexibility of landing zone in public cloud can be really expensive. Corporate governance should usually keep it under control. There are several recommendation APIs from Google Cloud to provide insights into costs and how to grow further with less cost. But it requires Active Assist, which is also the name of their new API for providing such service. And for this, a dedicated team should work on this topic to assist the platform team, platform operators, and workload developers at the same time to optimize the cost and ensure sustainability for the longer term, not restricting the innovation that way. It needs is this team. Usually, smaller companies cannot really have a dedicated team for this, but usually the cost optimization is more beneficial than the cost of having a dedicated team on that. Also, reaching a point to security controls. Public cloud is different than on-premise systems. It is in danger of attacks and misuse by stealing compute resources, crypto mining, such activities, and at the end of the month, the bill can really explode. To protect from that, we need security controls in place, security in depth, and a strong focus and another pillar for the landing zone. It is really important. Here you can see that on the left-hand side there are governance, risk, and compliance. That is important for by law. On the right-hand side there is security monitoring and operations. This is for operating the actual platform, the landing zone hosts. Looking into the logs, intrusion detection, cloud security command center to ingest logs and analyze threats and plan to protect from them. But at the same time, with security in depth, security exists in each layer. At the very bottom, there is this security infrastructure that Google provides us. On top of that, there are network security, like this software-defined networking with firewalls, cloud armor, such services, application security, for secure software supply chain, for the that affects the CI/CD pipelines. Binary authorization is important. If you allow deploying containers in a container management system provided by other teams, then we should rely on to have integrity of the container and tools to protect from misuse. And we also need to protect the data. Data security involves protecting sensitive information, PI information, with encryption, managing secrets, and so on. And also the actual identity and access management, that we shouldn't provide a way to attackers to have elevated permissions and end up as a disaster. Also, we would like to have the landing zone automated. Like there should be processes that are followed the same standardized way, optimized way, triggered by integration or as a simple activity like pushing a button. In this picture, we have some ticketing system, for example, ServiceNow, an on-premise environment that has an integration into a Git repository, either ops or ticketing help desk puts a commit into the the Git repository, or the ticketing system has it as an integration. It can trigger an automated deployment pipeline after some approval step. It can execute compliance validation steps, and it can create forgers, projects, VPCs, subnets, firewalls, and all the necessary other resources. So that way, this could be like for a cloud onboarding process. Any team within the company can request a new landing zone, a project for their cloud usage, and the automated pipeline can provision it. And this is also called in the Cloud Foundation Fabric as a project factory. But usually we have different implementations and integrations on top of that. So to summarize, what is a landing zone? It is an organization resource node. It has a billing account so that charges can be made against that. It uses automation. It uses mostly Git and Terraform in case of Google Cloud Platform. It can use blueprints off the shelf. Usually we take off-the-shelf solutions like Cloud Foundation Fabric and customize it to customer needs. And we implement self-service way of integrations. At the same time, it provides this structure, the identity management. It provides this hierarchy on the resources, tools, and way of doing the cost management. it provides secure networking, secure monitoring, security monitoring, and governance as well. So as a summary, but now let's step it into a bit deeper. What makes actually it being secure? Because what I just said, it is common to a landing zone. In specific to GCP, it is secure because it follows the Google recommended best practices with the highest level of security. There is a document from Google that they provide, which is called Enterprise Foundations Blueprint. This is a layered end-to-end approach. Even Cloud Foundation Fabric does not implement it fully, but it is a good start, and it summarizes all the concepts to have security in depth. There is also a Google implementation on the zero trust security model, which is different than that corporates have for on-prem. Like for on-prem, they differentiating secure networks from local networks, and they have this implicit trust. But within zero trust, there is no implicit trust. I will talk about that later a bit. There is also Google Cloud Architecture Framework, Google distributes to us, which summarizes all the best practices within system design that they also followed during the Enterprise Foundation Blueprint creation. And we also have centralized control of the landing zone, which means that there are detective security controls and preventive security controls. Some example, for example, detective security controls, they are monitoring. Preventive security controls, they are like organization policies. So to also talk about a bit of secure networking, defense in depth, security in depth. This means that from the very bottom to the top, we should ensure the security in each layer for each little bit. This involves IAM, firewalls, VPC networks, outbound connectivity to the internet. For example, or most of the customers require outbound NAT proxy, like a egress proxy, for example, Squid. They would like to filter out all the unnecessary network information or network connection to egress to public internet, and they just would like to allow communication only for the allowed list. VPN and interconnect to have a secure connection to on-prem system, protecting Google APIs by using private Google access with VPC service controls, and using some of the security best practices like identity aware proxy and also Cloud Armor with WAF capabilities, web application firewall capabilities for internet-based applications. Also, there are some nice security features like Cloud Firewall, threat intelligence for next generation firewalls, and cloud intrusion detection, for example. So security is a broad topic. All of the little components should ensure it and support it. I already mentioned zero trust security model. Google already has BeyondCorp Enterprise. That is an end-to-end security product, and this is originated from BeyondProd, Google's internal and cloud-native security solution that they implemented within their own organization. They learned from it, they collected the best practices, and they put into BeyondCorp Enterprise. So they productized it. This includes managed devices built into tools into the Chrome web browser, and also like device verification, things like that. So just talking about zero trust security model, this means that the access should not be determined by the network that the request comes from as implicit trust. It should be based on grant on the actual identity, actual device being used, like fingerprints, for example, and using MFA and two-step verifications. But it still can include some other factors, like what is the location of the request, where it comes from. There is a product called Access Context Manager, where all these extra requirements can be implemented. And based on these different factors, the rules engine can decide whether the access can be granted or not. But it is really not based on the network where the request comes from. So yeah, just one update to the previous topic, that imagine that an admin is on a flight to a conference where they have a speech, and he's in the hotel, but a serious event happens and he needs access. He cannot just travel back home to the office and have access from that. He needs access from the hotel's laundry room, and by having zero trust, he can just do that fine. And the next topic for this is like preventive controls, organization policies. So this is built into Google Cloud Platform, that at the top level, the organization resource node, we can define certain constraints. Because we already have IAM as permissions, we already want to have some constraints on the other hand to govern the cloud, and we can do it like creating org policies for those constraints at specific level of the resource hierarchy. We can restrict certain services used either this or that way, which is according to the security requirements of the corporate of the client. I have here some of the mostly used organization policies or constraints with the setting we enforce. You don't need to read it through. I will pick up some of you. So for example, there is a constraint for disabling external IP access for VMs. For compute VMs, we shouldn't really use external public IP addresses, because that will open them to the public internet, and we don't want that. Instead of that, we would like to use CloudNet or an egress proxy, or not have internet connectivity at all. To have security controls the other way, protecting Google APIs, the VPC service controls hubs. This is different than actual VPC. This is nothing to do with the VPC. VPC service controls will protect the Google APIs for a given project. For dry run, there are two modes, dry run and enforce. For dry run, it is detective controls, because for a violation, it provides log entries that we can monitor, investigate, and learn from it. Usually, this is done for workload during this assessment to go to production, that we create the VPC service controls in dry run, and we see that what actual violations it produces. We whitelist those, and when everything is whitelisted, then we enforce it for production mode, which means that for normal operation, it is capable of doing what it is necessary to do, but otherwise, all of the other activities will be prevented. On this picture, for example, you can see that with VPC service controls, we can also cut certain activity from the internet. Imagine that a Google Cloud Service account is stolen, the credential key is leaked somehow, and someone from under location tries to access the Google Cloud environment, and outside of the service perimeter, it is not possible to access to the resources, and violation will be logged. Next topic is data security. Like this is also a broad topic. Usually, from platform point of view, we need to ensure that encryption. Google encrypts all the data at rest by default, but we can also have customer managed encryption keys, and customer supplied encryption keys as well for added security. Most of the cases, customer managed encryption keys should be fine, and we can encrypt the data with it. And that way, as an extra protection, we can even protect it from any attackers from for example, from a hypothetical Google side. Secret Manager is useful to store secrets and provide it to applications and integrations, and also the data loss prevention API, what we can use to de-identify personal information from data, anonymize, and provide it for processing, for further processing. Confidential computing, like confidential VMs, which can not only protect the data at rest, but can also protect at run, for example, its memory and other aspects of that with the built-in security chip. Next topic is security monitoring. There are, as a detective controls, there are certain different services at Google Cloud that the landing zone should consist. For example, this is important for security admins within the landing zone to use Security Command Center, which can provide findings on misconfigurations. It has two or more than two different pricing model. One is the free, and there is a premium version, which has additional detection, threat detections. There is a service from Google which is called advisory notification, so that when some sensitive actions being taken on Google Cloud, a notification being sent out to the essentials contact of the landing zone. There is a community project called Community Security Analytics. What we found is usually is that like we have monitoring, but we are unsure whether our monitoring configuration is right. And Community Security Analytics answers that question really well, that it provides simple filters on logging that is important to watch out and put alerting behind that. Usually, so that is useful for log analytics and monitoring within the landing zone, but companies often require a second solution, a CM solution that we need to send all the logs to the on-prem side to have their own already existing CM solution. For that, we enable audit logs, and we can also use the CIS benchmark to assess the landing zone itself, the VMs, and different parts of the landing zone. So next topic is cloud governance. For governance purposes, there is a compliance resource center for audit reports, certificates. It answers all the transparency and privacy concerns. Google provides white papers on transparency and privacy parts. And there could be some corporate specific requirements that reusing existing components that they want to audit, and once they audit, they approve it for production use. They would like to provide it as workload blueprints for applications teams that they can use it to build up their own applications, which is production ready from the right beginning after testing. And they also want to have, as part of the landing zone, the platform team would like to have service descriptions, which defines all the provided services, the responsibilities, SLAs, tracing matrices for the landing zone itself. And also the cloud governance should ensure the naming and labeling conventions, and that is also ensured across whole the organization. So that is also important to have automation for that. All right. Next thing is like we arrived at CI/CD pipeline section. Here I'm mentioning like a barebone for such a pipeline. We usually have a version control system, which could be mostly a Git. We would like to perform code review on that. We can do that usually by having pull requests, merge requests. We want to build a code which could be like done by GitHub Actions, workflows, GitLab pipelines, Cloud Build, Jenkins, some other solution. We would like to have test running, test phase, that before actual apply, we would like to ensure that this will be fine. Terraform, what we usually have or use for landing zone deployment, has certain tools like validate and test. Validate will validate the syntax of the files. We also need to execute policy as code checks. For example, OPA, the Open Policy Agent, can be used to verify that the actual Terraform will execute only such changes which is approved by security and corporate governance requirements. Checkov can identify several security threats within the Terraform code. Terrace can also do that, such from Tenable. And Terraform introduced the test framework within, like in the recent 1.6 of its version, which is a great addition, I believe. Before that, we usually used TerraTest, which is a Go-based solution, but it required the team to learn different programming language. It was difficult to write tests that way. But with this new syntax, the same syntax as the Terraform files itself, the HCL syntax, Terraform unit and integration tests look really the same way how Terraform files look, and easy to write, easy to use, and they are very quick. And finally, at the end of the test, we would like to execute a Terraform plan. We would like to make it visible on the actual pull request or merge request, probably as a comment on that this will be the changes once it is approved, will be executed. And once it is executed, a deploy will happen, which is a Terraform apply in our case. Given that, what are the prerequisites for that? How the pipeline should authenticate? Nowadays, we don't want to use service account keys. We want to use Workload Identity Federation much better, which is actually an OIDC token exchange, a federated token and exchange, with additional service account impersonation. So that when the, for example, GitHub Action workflow is used, it provides a JOT token, which is provided by GitHub itself, which identifies which repository it is building, which branch, who is the creator or initiator of this build, and things like that, who is the actor. And it has this information within the JOT token. It has a connection between GitHub and Google Cloud by using a Workload Identity Federation user pool configuration that will provide trust to GitHub users for certain repositories, for certain actors within that actual project where the automation should, what the automation should target. So for that workload identity pool, this JOT token can be exchanged to a special federated token, which on the Google side is represented as a principal. And we can use IAM to provide permission for that principal to impersonate certain service account. And at the end, that service account can issue, or the secure token service can issue short-living tokens for that service account, and can provide it to the GitHub Action workflow. And that way, the Terraform execution can have access to the Google Cloud resources and can deploy all the resources that way. So the next thing is that the code review part. It is recommended to have a code repository where all the infrastructure as a code resides for the teams, for their projects, and they should be able to make changes against this repository. They should be able to open pull requests, so that way they can influence their code. And GitHub, both GitHub and GitLab has nice feature, for example, code owners. And by defining code owners, certain parts within the repository is changing. Certain different groups will be notified to provide review on the pull request. For example, when firewall configuration is changing, security admins or network admins can be notified. When org policy exceptions are made, then the security admins can also be notified, and they are required to do the code review on that pull request. When the pull request is merged, or before it merges, a plan is also added as a command, so that it will be easy to see that there is no need to navigate to the logs to see what will be the plan for this execution. It can be approved and executed. Next stage within the pipeline is like the test. I already mentioned that, and you can see it in the picture, that Terraform provides this new syntax for test files, which is easy to read for someone who is get used to write Terraform code. But it is also important to have security controls over the Terraform code, not just have tests. For example, tests could be useful for someone who creates Terraform modules, but also as a platform operator point of view, when we provide code repository for teams, they can write their own code. We would like to control them so that we only allow approved solutions, approved blueprints. We would like to deny the use of some malicious Terraform construct and things like that. We can use RIGO policies with OPA or Chekhov tests as a preventive controls. So when such an unsecure code is written into Terraform, it will fail the plan before it will be actually approved. And finally, the apply phase. When code review is done, test passed, plan is approved, then we apply the Terraform code, and we also need monitoring. When it fails, then we need to be alerted. And I collected some of the best practices. If you will have my slideshow, it is backed with a link. I collected all the little nuances as best practices from Google for use of Terraform for building landing zone. And now I would like to talk to you about typical workload blueprints that we deploy to the customers. Some of these are publicly available. In those cases, these diagrams, these images have links that you can follow. And for example, this blueprint I'm beginning with, this is image building process, an image building pipeline. It shows how we build golden images. And what does the golden images mean? They are actually security hardened images that we are building. We are packaging all the dependencies into a simple image, and we provide to the workloads to use, probably for some confidential computing use cases or something like that. We have a cloud build on the left-hand side, which triggers a build. It uses Packer, which provisions a temporary VM, and it uses CIA's benchmarking rules from Ansible lockdown. And that provisioner executes all the CI's recommendations, and it ends up a hardened image what we publish to artifact registry. And there is also an organization policy on the service project side that the project which hosts these artifacts, that is marked as a trusted image source. And that way, all the service projects can pull images from that project and just use. And the important thing here is that we have internet connectivity to the temporary VM during the building, but after it is not necessary. So the hardened VM has all of its dependencies, all of its software and patches, so that there is no need for having a internet connectivity afterwards. Next workload blueprint is the recommended architecture for internet-facing applications. which is using a load balancer integrated with Cloud Armor. And Cloud Armor also has an internal web application firewall, WAF, which protects the application from DDoS type of attacks. So this is also available as a blueprint from Cloud Foundation Fabric. There is a link to that. Next blueprint, what we usually have, this shows a use case for secure software supply chain when there is a CI/CD pipeline for building images and as a second step to deploy those into a GK cluster. And it could be that these different users could be, for example, from different companies without any strict contract, without any specific contract. The way how they ensure that the build image is consistent, it remains this integrity, is using binary authorization. Google Cloud Platform provides this feature, a way that the build images, when published to your image registry, can be attested, which means that by using cryptographic keys, it has a kind of certificate which can be verified. And on the other side, where these images are consumed, binary authorization policies can be written which accepts certain attestations being done. And that way we can ensure that these images are not tampered with and remain secure, the binaries for that. Our next workload blueprint, it shows a private service connect as a private and secure way of networking. And this works within different GCP organizations where VPC peering or shared VPC cannot be used. The way it is working, there is endpoint group on the producer side. There is a service attachment for that, and that is advertised. On the other side, there is an endpoint which subscribes to that service attachment. And in that way, the consumer VPC can consume this service. The endpoint is like a reserved IP address for that service attachment. And in between, under the hood, Google uses load balancers to ensure the connectivity between the two. There is also implementation from Cloud Foundation Fabric for this blueprint as well. Next workload is a secure CI/CD setup where not workload identity federation is used, but a more fine-grained solution. It uses vault servers from HashiCorp. And this way, for example, in a multi-tenant setup, when there are different teams building their code via such CI/CD implementation, they can request team-specific credentials from the vault servers so that the automation also follows the least privilege principle even for such multi-tenant system. And it is considered very secure in that way. Next topic is integrations, IAM and billing. Usually we deploy as a starting point the Cloud Foundation Fabric, which is an open-oriented landing zone implementation of the Security Foundation's blueprint. We configure federated identity for SSO and identity synchronization and for edit features. We also implement a billing dashboard used or implemented with Looker Studio. Google provides example implementation on that. We also use FinOps Hub to show recommendations for the customers. And there is also an automation for budget capping. For some cases, they would like to apply several actions when the budget alert is firing. For production, it could be notification. For development projects, it could be actual capping by detaching the billing account from the actual project, or we can just stop running VMs when the budget is overutilized. We also have another solution for our customers, which is like on top of the Cloud Foundation Fabric landing zone, we integrate with meshcloud.io, which is a fully-fledged cloud platform management solution, but a third party that we are not selling actually, or customers can opt into those. So next topic is the CM integration. Usually we implement it with an aggregated sync on log router. That is a GCP native logging feature to capture all the organization-wide logs with specific filters from Google Cloud Platform. We set a destination to PubSub topic, and also we save it to cloud storage. And in some cases, we can also send it to BigQuery, so that with log analytics, with added BigQuery capabilities, it can be like a real-time system to search for the logs. But via the PubSub solution, we can synchronize these logs to third-party SIEM solutions, most probably sitting on-prem side, but we can also send these logs to Chronicle CM solution, which is an enterprise solution for CM monitoring for Google Cloud Platform. And finally, the last integration I would like to mention is a case for break-glass scenario, which means that for emergency situations, for example, a superadmin of cloud identity, we can somehow get lost. For example, attackers gain access and try to lock out us. In that case, we can use automation. There could be a service account with domain-wide delegation to provide access to cloud identity itself. And we have an automation where we store users, roles, and their assignments in a NoSQL database on GCP. And when a change happens to those documents, we initiate a cloud build. Also, the event is saved or sent to a PubSub topic. Cloud build executes the provisioning of the users and their accesses within the cloud identity. It can restore superadmin access, and it writes a feedback back to the NoSQL database. So that way, normally we can provide permissions, for example, operations team, but also we can ensure that for emergency situations, we can regain access to cloud identity as superadmin. Next, I would like to show you some of the recorded demonstration of the automation, namely the project factory from Cloud Foundation Fabric, how it works. So the important thing here is that there is an empty folder that I'm going to define a project for. Here in Cloud Shell Editor, I have the Git repository checked out. And for a folder under data/project, I'm creating a YAML file where I define the project to be created. It uses a concept called resource factory. When I don't need to write any Terraform code for it, it uses its own YAML syntax, and multiple files can be created, one per each project being created. So I define some of the details. File name will be used as part of the project name. Within the file, I'm defining some essential contacts, folder ID where this project will be saved, and also some of the configuration, like what services to be enabled. Now I'm committing it into the Git. So this follows GitOps approach, and I'm syncing these changes. and it should start a CI/CD pipeline within a connected GitLab instance. So meanwhile, it starts. Let me show you how this pipeline looks like. At the very beginning, I'm saving the JOT token from CI to a file, and also I'm having an alias on the GitLab URL. I'm also defining some of the variables here to use. For example, there is configuration where the token exchange, which file it will be saved into. Also a cloud storage bucket where the outputs live. Those are the outputs of earlier stages of Terraform executions for Cloud Foundation Fabric. So that will be the input for these automation as well. There is a service account being defined that will be impersonated during the Workload Identity Federation, and also the Workload Identity Federation specified. That is the established trust between this GitLab instance and the target GCP system. And I also define the provider file and the variable files to fetch from the output bucket. So there are 4 stages: authentication, files, copies the files from the output bucket, executes plan, and apply. The authentication works like there is a gcloud command which creates a token configuration for the token exchange, a federated token exchange. It saves to a file I was specifying. The next step is saving the files from the cloud storage bucket into a temporary folder locally. So one provider file and multiple variable files will be saved. And at the beginning of the plan, copying over these files from the actual folder, from the temporary folder, and execute Terraform init, validate, and plan. And usually we save a plan, so the apply should use that actual plan. And for the plan, it is important to mention that it should be one manual, which means in GitLab, this means that this job will not be automated, will not be executed automated way, that we need to trigger it manually. And it also has a configuration only when variables are equal, which means that the committed branch should be the default branch. In this case, it should be only executable this step when the target branch is master. So for example, for feature branches, we shouldn't be able to execute the Terraform apply. So meanwhile, I was showing that the preparation steps are done. We can look at the actual Terraform plan. There are some output variables of this stage as well. It will create some of the resources. For example, Google Project Service resources are the APIs to be enabled, storage, stack driver, org policy, essential context, compute, billing budgets. It also has IAM binding for a user group to be compute admin. It creates the new project. It specifies the forgers, the billing account for that, and labels. It also defines some of the essential contacts for the budget alert to be, so that when a budget alert is firing, it will use that email channel as a notification channel, and it will send the emails to the essential contacts. And also the budget alert has its configuration. So what are the thresholds? What is the amount to be specified? So it looks good. We can trigger the apply. It takes a few minutes usually to apply such code. So for convenience, that is also edited. After 2 minutes, project is about to be created. And apply was successful, and so that the provision was done. And let's see that the project is created on the Google Web Console. So after refreshing the page, and see that on the mentioned target on Teams under TSI admin under development, there is a new project called TSI POC Meetup. And this was the purpose of this automation. So that concludes my presentation, also the demo. And do you have any questions? And thank you. So the first question, can we keep the data inside the EU or even inside Hungary? So Google Cloud has a relatively new product called Sovereign Cloud, which is their answer to address the need for GDPR compliancy. And we can use the Sovereign Cloud of Google Cloud to ensure that the data remains inside EU. The unfortunate part is that not all of their actual service is available by this. And we cannot really restrict it only Hungary because we don't have a point of presence here, data center here. So sorry, can I just continue? So please indicate that if you are not happy with the answer. Next question is that what is the cost impact of having a landing zone? So that's nice. That's a tricky question because most of the resources as a baseline or by deploying the Cloud Foundation Fabric does not cost anything. It just costs a little based on the traffic and the amount of little data that is stored. And usually there is also the free tier of Google Cloud that within the free tier, there will be no cost but otherwise, for example, for Cloud Security Command Center, the premium version is quite costly. They're quite expensive. There are also several other services that when enrolled, for example, the next generation firewall or some other services, they can be a bit costly. So there is the need to cost optimization. And yeah, that is a whole topic on its own. Next question would be like, is it recommended to have such landing zone for smaller companies? I would say that at least they should have the enterprise checklist being applied, that is targeting even personal accounts. And after it, some of the concept or even some of the stages from Cloud Foundation Fabric should be deployed and should be used. The main thing here is that it should be really used. Otherwise, it makes no sense to deploy something which is not maintained and insured. But I would recommend even smaller companies should do it, but with the fine tuning to their needs. So they don't have such big teams. They have shared resources or shared personal scenarios. It should support their work. Is it different to have landing zone in GCP than other cloud providers like Azure or AWS? I would say no. So the whole idea should be the same, and only the differences, little differences within the actual tools or services that should influence it. But otherwise, the whole concept should be the same. Next question. While planning the move from on-premise to a landing zone, one of the biggest challenge from financial point of view is the significant change from CapEx to OpEx. Is there any best practice to handle this? According to my experience, it is really the answer for this question is in the details. So we should have a plan. We should build a plan, and so we already have a design for landing zone. We discuss it with the customer, and we have a plan for the migration itself. And this is really the discussion and having an approval on that plan and have an effective execution on that. So there are no easy shortcuts there, I guess. There should always be compromises. But the reduced cost on one hand can allow some other cost being spent some other way.
Thanks so much. I don't see any more questions. So let me thank you, Tamás, for your insightful presentation. And of course, thank you for everyone in the audience for joining us today. I hope you enjoyed this session. If so, don't forget to join GDG Cloud Budapest community so you don't miss out on future events like this. And remember, the recording of this meetup will be available on the Clouders Club YouTube channel. Thanks again for joining. Have a nice afternoon.